Welcome to your homework support video for constructing triangles. This is in your packet on page 8. So in your first question, this is a multiple choice question, and it is possible to have multiple answers. So which of these descriptions of a triangle ABC are directions that can be followed to draw exactly one shape? So you might think about what we did in class today and how we talked about how if we give you certain pieces of information, they will only produce one triangle. However, other pieces of information might produce more than one. So for example, in A, we've given you a side length, so 2.5 for AB, another side length of 2 inches for AC. I'll draw that in a second here. And then B is 40 degrees. So if you think about B being 40 degrees, you might envision how I could have probably a length of a C here that is 2 inches. Or I could maybe even have a length of C that might be drawn a little bit differently, right? That could go in further. If this was extended further, I might be able to also make a 2-inch line. And so there's actually multiple possible triangles that could be made from this information. So this, A, does not produce exactly one shape. In the case of B, I'm given a side length. So again, AB is 2.5 inches. I'm going to label that here. I'm given AC is 1 inch, and also angle A is 40 degrees. So I'm going to sketch an angle A of 40 degrees and label AC as 1 inch. Again, I know my drawing's not quite to scale, but thinking about what we did in class today, if I draw those side lengths to scale, the side, the angle, and the side, then that can only produce one triangle because there's only going to be one other side length that could fit right here between C and B. So B will produce one unique triangle. Looking at C, I have AB is 2.5 inches and angle B is 60 degrees and angle A is 40 degrees. And so again, you might think about what we did in class today. We talked about how if we have this kind of information, really there's only one possible way for those to connect. I've been given a side, an angle, and an angle. Again, you're going to learn more about this in high school geometry. But there's really only one triangle that I can make out of that information. So C is also a way to draw exactly one shape. And finally, we have D. And in D, they tell us that length AB is 2.5 inches and that angle B is 60 degrees and angle A is 130. And so if I think about this here, maybe 130 degrees. Should probably make it a little bit bigger actually than that. 130 degrees. You can probably start to visualize that there's not going to be a triangle that's possible with this. And if you think about it, you actually know what the angles of a triangle should add up to. And that should be 180 degrees. And so looking at these two here, I have 130 plus 60. That makes 190 degrees. So even if my drawing here isn't maybe the best to make sense of this, you might envision it going even further out this way. Technically, these will never connect and form a triangle. They have a larger angle sum than 180 degrees. So again, you're going to want to talk here and explain your reasoning about how B and C will work, and talking about how in one we know a side, an angle, and a side. In the other we know a side and an angle and an angle. And so those are combinations that produce only one triangle. So now we're looking at question number 2, and you're being asked to construct some triangles with a ruler and protractor. So please make sure as you're drawing these that you're drawing them really accurately. And so in the first case, we're asked to draw an equilateral triangle with sides of 1.5 inches. And we gave you a little hint here to also think about the angles of an equilateral triangle. So again, you know that the angles in a triangle add up to 180 degrees. And so if you imagine an equilateral triangle is 3 equal sides, and it also has 3 equal angles, you might have noticed, I can figure out that 180 divided by 3 would give me 60. So each of those angles inside of an equilateral triangle is 60 degrees. So if you think about what we've been doing in class, we've talked about starting with an angle. So if you draw a 60-degree angle, that's a good place to start. Then make each of those side lengths 1.5 inches. And at that point, if you've drawn them to scale, you should actually be able to connect that line and form 2 additional 60-degree angles. So next you're going to see an example of what it should look like approximately. So I realize I should have made that 1.5 as well. So when you look at your triangle, make sure that it has equal sides of 1.5 inches as well as 60-degree angles inside. On the second one, we're being asked to draw a right triangle with legs of 1.5 inches and 1.75 inches. So again, we've talked about starting with the angle. So sketching a right angle, and then you can choose where the side lengths go. For example, here I might put my 1.5. Here I might put my 1.75. And then I'm going to go ahead and connect those. So again, I know your drawing is going to be a lot more precise and crisp than mine, but when you construct it, it should look approximately like this. For the third, we're looking at a triangle with a 25-degree angle and legs of 2.25 and 3.75 inches. So again, make sure you're starting with that angle, 25 degrees. Then your legs, so 2.25, 3.75, however you're going to construct it, and then connecting them together. Again, your finished product should look something like this. If it was turned to the side, mine is just kind of a rough sketch. Again, make sure you have each of those components. And finally, we have a triangle with a 70-degree angle with sides of 1.5 and 2.25. So again, please start by setting up your angle and then adjust your sides. So if I do this as 1.5, 2.25, and I can connect those guys together. And so again, here is an example of a finished product that yours might look like. Again, just look through carefully and make sure that you have each component. So tomorrow in class, you're going to be exploring more with angle relationships related to complementary, supplementary, what we call vertical and adjacent angles. And so make sure you're ready tomorrow to think about the angle relationships you already know and add a few more to your toolkit.